Hi, hello everyone. Welcome back to Nexen Academy. This is Madhusudan, Department of Physics. In the last session, we have seen relative velocity in one dimension and also two dimension. And today, we are going to discuss the projectile motion, a very important topic for the NEET as well as for JEE. We are going to start that. Let me take look at this. First thing, we should understand the definition of a projectile. Whenever a body is projected into the space with an angle with some velocity, with an angle other than 90 degrees, with some initial velocity, that is called a projectile. So angle of projection should not be 90, other than 90 degrees we should take with some initial velocity. So that is called a projectile. A body projected into the space at some angle other than 90 degrees with some initial velocity is called a projectile. So look at some diagrams, some pictures we have here on the screen. Look at this. This boy is throwing a ball with some velocity into the space in this way. It is following a path. This path is nothing but a projectile. So this is what the trajectory of a body. Trajectory of a projectile is a parabol that we are going to prove mathematically. But here look at this. Here it is a cannon. This cannon is also following a parabolic path, and this one here, a boy is throwing the ball at some angle with some initial velocity. This one is also following a parabolic path, and here it is a gun, it is firing a bullet, and it is following a parabolic path. So therefore, if a body is projected at an angle other than 90 degrees, that follows a parabolic path. It is a usual thing. If you observe a long fielder in cricket, that long fielder is throwing a ball towards a wicket keeper, that ball follows a parabolic path, right? We have a wide variety of examples for this projectile in real time also. If you take a shuttlecock or a throw ball, lots of examples we have on this projectile. Okay, so here we are going. First thing is, we are going to prove the path of a projectile is a parabola. Mathematically we have to prove. Now listen, here we have, here it is y-axis and x-axis. A body is projected into the space at an angle theta, in this way. This one is the angle of projection, and here is the velocity of projection. This one is initial velocity with which a body projected. Angle of projection is theta, and here it is a point of projection. This initial velocity or velocity of projection can be resolved into two components. What are those? Means one is a horizontal component along x direction and vertical component perpendicular to the horizontal, or we can say this one is horizontal component in this way. Ux is equal to u cos theta. This one we know, we should know how to resolve a vector. A vector can be resolved into two components. One is horizontal, another one is vertical. U cos theta and u sin theta. These are the two components of velocity. Okay, right. Now how do we write this initial velocity vector? Means this is u bar is equal to u cos theta I cap plus u sin theta j cap, or you can write this as ux I cap plus uy j cap. This one is u bar. Initial velocity vector is u cos theta I cap plus u sin theta j cap, or ux I cap plus uy j cap. That is the initial velocity vector. Now this motion of the body, motion of the projectile, I am going to discuss along two directions separately. Means I am going to resolve this motion into two directions separately. One is horizontal motion, another one is vertical motion. So first thing, horizontally separately, vertically also separately we are going to discuss, right? So let me take the horizontal motion or along x-axis, separately. Along x-axis if you take, separately the discussion. Along this direction, body has only velocity u cos theta. Is there any acceleration to the body, to the projectile? Means no acceleration. Body is having only velocity, that is ux is equal to u cos theta. Body has only in this way u cos theta. Okay. When it comes to the vertical direction, in this vertical direction also body has some velocity, initial velocity u sin theta. Okay then. Now here, at any instant of time, let's imagine this body is here. At any instant of time, body is at the point P. This point has the coordinates x comma y. At any instant of time, let's imagine the point P, means the body is at a point P which has the coordinates of x comma y. Now coming to this, here ux is equal to u cos theta and horizontally displacement is equal to x. And what about acceleration? As we discussed, no acceleration. No acceleration means, can we say that velocity remains constant? Horizontal velocity remains constant. So this is a very important point while solving the questions on projectile. Horizontal component of velocity throughout the motion of the projectile remains constant. U cos theta is equal to, together u cos theta remains constant throughout the motion of the projectile. So here this one, ux is equal to u cos theta, horizontal component remains constant throughout the motion because no acceleration, remains constant throughout the motion, throughout the motion of the projectile, Okay then. Now we know that displacement s is equal to horizontal velocity into time plus half a t square. Here acceleration in horizontal direction is equal to 0. Therefore only this displacement is equal to velocity into time. This can be x is equal to u cos theta into time plus 0. So why it is 0? Because acceleration is 0. No need to consider. And this x is equal to u cos theta into t. This is the relation between x, u, cos theta and time. That's the relation. Okay. So horizontal distance is equal to x is equal to u cos theta into t in a time interval t. Now from this, can we write time taken is equal to as x by u cos theta? This one we can write. This is the relation between time and x, or we can say horizontal distance and the time taken. Okay then. When it comes to the vertical direction, here I'll take y-axis. Right. Along y-axis, if you take, velocity, initial velocity uy is equal to u sin theta and acceleration ay is equal to minus g. So why do you take negative sign here? Negative sign we have to consider because acceleration due to gravity is acting downwards. It is pulling the body downwards. Body is trying to move upwards, but acceleration is trying to pull downwards. So acceleration here it is negative. So we are taking ay is equal to minus g. Okay, right. Next, in this case, displacement is equal to vertical displacement in a given interval of time is equal to y. Now, how do we relate all these quantities? Right? How do we relate all these quantities? Means we have a relation. That s is equal to ut plus half at square. Displacement of a body in a given interval of time is given by s is equal to ut plus half at square. In this formula, S is equal to Y. This Y is equal to U means Uy here, that is U sin theta into T minus half G T square. So why do you take minus G? Already we defined acceleration as negative minus G. So instead of A, I have substituted here minus G. So therefore, Y is equal to U sin theta into T minus half Gt square is the relation we got, right? Now in this context, what is the time? In terms of, one second, in terms of time, this is the relation for Y. In terms of X, we have to derive. So here, X is equal to, here it is, T is equal to X by U cos theta. In this case, U sin theta, time, instead of time, we have to substitute that expression X by U cos theta minus half G T square as X square by U square cos square theta. Now in this formula, what is sin theta by cos theta? That implies this Y is equal to, Y is equal to, now you tell me here, this sin theta by cos theta is equal to tan theta, can be right? Sin theta by cos theta is tan theta. Also this U and U can be cancelled out. U and U can be cancelled out. What's the remaining here? Tan theta into X minus half into G X square by U square cos square theta. This can also be written as, Y is equal to AX minus BX square. Y is equal to AX minus BX square. Here you may ask, sir, what is A and B? Where A is equal to tan theta, A is equal to tan theta, and B is equal to G by 2 U square cos square theta. So these are the two constants we are assuming. A is equal to tan theta, B is equal to here 2 G by 2 U square cos square theta. If you substitute these two constants, this displacement as Y equal to AX minus BX square. In mathematics, this equation indicates what? This equation indicates a parabola, right? So path of a projectile is a parabola because this equation mathematically indicates a parabola. Hence, the conclusion is trajectory of a projectile is a parabola. Mathematically, we proved that the trajectory of a projectile is a parabola. Here, what's the conclusion? Trajectory of a projectile is a parabola. Mathematically, this equation Y is equal to AX minus BX square indicates a parabola. Okay, right. So this is a very important conclusion. They'll ask the questions like prove that the trajectory of a projectile is a parabola. So this one we have proved. Y is equal to AX minus BX square, right? This indicates a parabola. And in this context, usually they'll ask questions as what is the time of ascent, what is time of descent, and horizontal range, maximum height. These questions they'll ask. Okay, so time of ascent means what? Observe this diagram carefully, or we will take separate diagram. Once again, we'll take separate diagram. Look at this. This one is horizontal component U cos theta, and it is vertical component U sin theta. Now, this vertical component has the acceleration. As a result, what happened means velocity in vertical direction continuously changed. Velocity actually in the upward direction, acceleration is in the downward direction. As a result, velocity vertical component continuously decreases, and finally at one point vertical component of velocity becomes zero, which means, look at this. This is the point where vertical component of the velocity zero. Okay, at this particular point, the height attained by the body is called maximum height attained by the projectile. Height at which the vertical component of the projectile is equal to zero, that height is called maximum height. Also, the time taken by the projectile to reach this point where the vertical component of velocity is zero, that time is called time of ascent. Time of ascent means from the point of projection, time taken by the projectile to reach the maximum height or to reach the point where the vertical component of the velocity is zero, that is called time of ascent. Okay. Similarly, time of descent, time taken by the projectile to reach the point of plane of projection from the maximum height is called time of descent. Okay, right. And here, what is horizontal range? Horizontal distance traveled by the projectile, horizontal distance traveled by the projectile before striking the ground, is called horizontal range. So on all these factors, usually we will get questions. Time of ascent, time of descent, or a time of flight, means total time in which the body is flying is called time of flight, or maximum height or horizontal range. On all these factors, usually we will get questions. So one by one we will derive the quantities. Now listen, as we have the data along y-axis. What's the data we have along the y-axis? What's the data we have? Uy is equal to u sin theta, ay is equal to minus g, and the time of ascent ta, time taken, is equal to time of ascent here, and here vertical component is equal to 0. Vertical component of velocity is 0. So how do we relate all these quantities? Means we have a relation among the quantities is equal to v is equal to u plus at. So here v means 0, u as u sin theta minus of g into ta. You can write this as u sin theta is equal to g into ta. U sin theta is equal to g into ta, or this ta is equal to u sin theta by g. This is the time taken. Or you can write this as ta is equal to uy by g. Uy means u sin theta. Usually, in case of a body projected vertically upwards, we have studied that T is equal to U by G. Here also same kind of formula, Uy by G. Instead of U, we got Uy by G. So that is U sin theta by G, time of ascent. Okay, right? Fine. Similarly, we can prove. I don't want to prove that. Similarly, we can prove that time of descent is equal to U sin theta by G. Same kind of procedure we will follow, and same expression also we will get. U sin theta by G. Okay. So here time taken by the projectile to reach the plane of projection from the maximum height as the time of descent, and this is the formula. Okay. Right. So here time of descent is equal to, we got the same expression as U sin theta by G. Okay. Next one is maximum height. We will derive maximum height means where the vertical component of velocity is 0. Now here in this case, here it is maximum height we will take maximum height. So here we have a relation that is v square minus u square equal to 2as. V square means 0, u square as uy square, that is in this way you can write as y. So uy square means u square sine squared theta equal to minus of 2g into h, because where this vertical component is 0, that vertical displacement as h we are taking. So here vertical displacement is equal to h. Vertical displacement is equal to h. We are taking that h, vertical displacement. Here it is. Now from this we can write u square sine squared theta is equal to 2gh. This h is equal to u square sine squared theta by 2g. This is the maximum height attained by a projectile. This can also be written as h is equal to uy square by 2g. In case of a body projected vertically upwards, we have studied as h is equal to u square by 2g, and this one here it is h is equal to uy square by 2g, similar kind of expression. H is equal to u square sine square theta by 2g. Clear? Okay. Next. And one more important quantity is here horizontal range. Horizontal range. One more important quantity is horizontal range. Look at this. Here we have horizontal range in this way. Same horizontal component of velocity as u cos theta. Vertical component of velocity as u sin theta. In this case, horizontal distance traveled by the body we have to find. So here you tell me one thing. Horizontally distance we have to find. Means horizontally velocity we have to consider. Horizontally acceleration we have to consider. Both we have to consider. Right? Fine. Now, as we discussed it, along x-axis, is there any acceleration to the body? Horizontal direction. No acceleration. Acceleration is 0. But velocity is equal to u cos theta. Displacement is equal to horizontal range as r. No acceleration. Time taken is equal to what? Time taken is time of flight. Time of flight means total time, which is nothing but time of ascent plus time of descent. So here we can write horizontal distance is equal to horizontal velocity into time taken. Okay. Okay. Here what is the total time taken? Total time taken is equal to time of ascent plus time of descent as time of flight, that is u sin theta plus u sin theta, both we have to add up, that is 2u sin theta by g. 2u sin theta by g. This is the time period. This is the total time of flight. Okay, right. Now here in this context, this r is equal to ux into t we can write. That implies r is equal to ux means u cos theta and t is equal to 2u sin theta by g. That is, in mathematics trigonometry we know that sine 2 theta is equal to 2 sin theta cos theta. Based on that, this can be rewritten as u square, u into u square sine 2 theta by g is the horizontal range. So these are the parameters. We must know about the projectile. What are those? Time of ascent, time of descent, time of flight, horizontal range, maximum height. All these parameters we should know. Then only we can solve the questions on projectile. Right? Okay. Right. So far we derived the expression for the horizontal range, maximum height, time of ascent and time of descent. also few more parameters we need to discuss on projectile. Now look at this diagram carefully once again. Here velocity, if you take at this moment, this is the direction of velocity, velocity direction here, and acceleration, if you take at this particular point, this is the direction of acceleration, vertically downwards. Now angle between velocity and acceleration, if you take, that is theta 1, that theta 1 is more than 90 degrees. Similarly, if you take here this angle, let me take it is some u2, and here it is some theta 2. So this angle in this way, sorry, small correction, right, theta 2, and this is acceleration due to gravity. And at this particular point velocity is u3, and here it is acceleration, and this angle is 90 degrees here. And further this can be velocity u4 and acceleration due to gravity g, and at some other point velocity u5 and acceleration due to gravity. Angles are here theta 4, theta 5 here. Now if you observe, in the first half velocity and the acceleration, if you observe velocity and acceleration angle, if you take, this angle is less than 90 or more than 90. This angle is equal to okay. So if you observe this diagram, carefully, here we have first half. First half means during ascent, the acceleration and the velocity, these two are subtending an angle more than 90, obtuse angle, and here also obtuse angle, means the angle between velocity and the acceleration is more than 90 degrees. At the maximum height, if you observe, angle between velocity and acceleration is exactly 90 degrees, means velocity and acceleration are perpendicular to each other. And also second half, during descent, velocity and acceleration angle is less than 90 or acute angle, and here also less than 90 acute angle, right? So here few conclusions we can take from this, so that is, first one is during ascent, angle between velocity and acceleration, is greater than 90 degrees. It is greater than 90 degrees. Similarly, during descent, angle between velocity and acceleration, is less than 90, or we can say acute angle. At maximum height, third one, at maximum height, velocity is perpendicular to acceleration. Which means angle is equal to exactly 90 degrees. Okay. Okay. Next one. Another one. Now look at this. If you take this projectile, here we have angle of projection is equal to theta, angle of projection is theta, velocity of projection is equal to u, and we have r is equal to u square sine 2 theta by g, u square sine 2 theta by g. This is the horizontal range of the projectile. Horizontal distance traveled by the projectile is u square sine 2 theta by g. This horizontal projectile will be maximum at which angle? At which angle it is maximum? If you observe this, if this sine 2 theta is maximum, automatically horizontal range will be maximum. So when do we say this sine theta is maximum? Means when sine theta is equal to 1, that's the maximum value of sine theta. So here sine theta means sine 2 theta is maximum, means that 2 theta must be equal to 90 degrees. When 2 theta when 2 theta equal to 90 degrees, r will be maximum, means horizontal range will be maximum, right? So sine 2 theta equal to sine 90 becomes 1. So sine 90 equal to 1 in the sense sine theta is maximum, means horizontal range also maximum. So here when 2 theta is 90, this r becomes maximum. So this r max is equal to u square sine 90 by g, which is equal to u square by g. This is very important conclusion while solving the questions. Maximum horizontal range is equal to u square by g, which means theta is equal to what? 2 theta 90 degrees means for which angle it is? Theta is equal to 45 degrees. So r is maximum when theta equal to 45 degrees. Okay, right. Next, another thing here, we have complementary angles. We have another concept, that is complementary angles. Complementary angles means for the same projection velocity for two given angles, horizontal range will be same. Those two angles are complementary angles, right? Which means projection velocity will be same, angle of projection differs, but the horizontal range will be same. Such kind of angles are called complementary angles. Look at this diagram so that you can understand. Here it is, one body projected with some angle in this way. Let me take it is some value theta 1. Another body is projected with some different angle. Here this one is theta 1 and this is theta 2. Two different angles. Projection velocity is same. Horizontal range will be same. For the two bodies for two different angles, theta 1 and theta 2. Theta 1 and theta 2 are called or complementary when theta 1 is equal to, when r1 is equal to r2. If horizontal ranges are same, then we can say that the two angles are complementary. R1 is equal to R2. Horizontal ranges are same. So here, when do we say this R1 is equal to R2? R1 is equal to R2 means here two possibilities are there. What are those? Means sine 2 theta 1 is equal to sine 2 theta 2. Here u square, same projection velocity, sine 2 theta 1 by, in this way, is equal to u square sine 2 theta 2 by g. Okay, so here sine 2 theta, u square cancel, g and g can be cancelled out. Here two possibilities are there. What are those possibilities? Means look at this. What are those possibilities? Means theta 1 is equal to theta. First possibility it is theta 1 is equal to theta. Theta 2 can be 90 minus theta. Theta 2 can be 90 minus theta. Theta 2 can be 90 minus theta. If you observe sine 2 theta, sine of this one 2 theta 2, here 2 into 90 minus theta becomes sine 180 minus theta is equal to sine theta. So both R1 is equal to R2 for angles theta 1 is equal to theta and theta 2 is equal to 90 minus theta. The angles will be same. Also for theta 1 is equal to 45 minus alpha, theta 2 is equal to 45 plus alpha. These are the two set of values for the complementary angles. Okay. So for a given velocity, horizontal ranges are same for two kinds of angles. Those are called complementary angles. Okay. Right. Next. Here for complementary angles, first point is R1 is equal to R2. R1 is equal to R2. What about H1 and H2 relation? This H1 is equal to H1 is equal to U square sin square theta by 2g and H2 is equal to U square sin 90 minus theta by 2g, because theta 1 is equal to theta 2 equal to 90 minus theta. This H2 is equal to you can write U square cos square theta by 2g. Now you can write H1 plus H2 is equal to as U square sin square theta by 2g plus U square cos square theta by 2g. This can be U square by 2g, that is because sin square theta plus cos square theta is equal to 1. Sin square theta plus cos square theta is equal to 1. So therefore you can write H1 plus H2 is equal to U square by 2g. H1 plus H2 is equal to U square by 2g. That's the second conclusion on complementary angles. Also, if you take a product, that is third one, here I'll write third one is H1 into H2 if you write, H1 into H2 if you write, that is U square sin square theta by 2g into U square cos square theta by 2g. You can write this as U square sin theta cos theta by 2g whole square in this way. U square sin theta cos theta by 2g whole square you can write, or you can rewrite this as U square sin 2 theta by 4 into 4, that is we can take 4 and 4, that is 8 into g. 1 minute. Right. Now if you multiply this numerator and denominator with 4 in this way, U square sin theta cos theta by 2g whole square, this can be written as U square, 1 minute, one small correction, 2 by 2 is enough to bring that into sin 2 theta. U square sin 2 theta by 2 into 2g in this way you can write, or 4g you can write whole square, or this can be written as r square by r square by 4, r square by 4 you can write, r square by 4 you can write. So therefore h1 into h2 is equal to r square by 4. So therefore this one 4 square here. So that is r is equal to 4 into square root of h1 and h2. This is the relation. R is equal to 4 into square root of h1 and h2. These are the relations for complementary angles. Okay. We will take some questions on the projectile. Right? Okay. Now, so look at this question. Look at this question. Two projectiles, two projectiles two projectiles A and B are thrown initial velocities 40 meter per second, 60 meter per second at angles 30 and 60. Two different bodies these are with horizontal respective. The ratio of their ranges respectively, that is H1 by H2, sorry, R1 by R2 we have to find, R1 by R2 we have to find. Horizontal ranges they are asking, R1 right. So R1 by R2 is equal to U square means U1 square sine 2 theta 1 by U2 square sine 2 theta 2 we have to find. This is equal to U1 square as 40 by 60 whole square sine 2 theta 1 sine of 2 into 30 degrees by sine of 2 into 60 degrees. This one is 0, 0 cancel. 2 by 3 it becomes 2 by 3 it becomes 2 by 3 whole square can be sine 60 and also this becomes sine 120 sine 60 degrees by sine 120 degrees it becomes. So this is equal to 4 by 9 into 4 by 9 into sine 60 is equal to root 3 by 2. Also sine 120 becomes sine 90 plus 30. Sine 90 plus 30 becomes cos 30. Cos 30 is equal to once again it is root 3 by 2. This root 3 by 2 can be cancelled out, which is equal to 4 by 9 is the answer. 4 by 9 is the answer. So very first option is our answer. 4 is to 9. Okay. 4 is to 9. A simple question, direct formula based question. Okay. Right. So look at the next question. Look at the next question. Here we have two objects are projected with same velocity u. However, at different angles alpha and beta with a horizontal. Two different angles. And if alpha plus beta equal to 90 degrees, alpha plus beta equal to 90 degrees means it indicates they are which kind of angles? They are complementary angles. For complementary angles, what's the condition? For complementary angles, we know that R1 equal to R2, R1 equal to R2, nothing but R1 by R2 is equal to 1 by 1. Here the question also said, the ratio of horizontal range of the first object to the second object will be, ratio of horizontal range of the first object to second object will be 1 is to 1. Nothing to discuss here. Only the thing you should identify they are complementary angles. Theta 1 equal to theta 2 equal to 90 minus theta means theta 1 plus theta 2 automatically 90, right? Okay, next. Let me take the next question. Here it is. A stone is projected at angle 30 degree, at an angle of 30 degree to the horizontal. The ratio of kinetic energy of the stone at point of projection, to kinetic energy at the highest point of flight will be, So let me take the diagram so that you can understand this. in this way. At the point of projection, velocity u, angle of projection is theta, and at the maximum height, its velocity is equal to only horizontal component, that is u cos theta. Vertical component becomes 0. There will be no vertical component at maximum height. Now the question, kinetic energy initially equal to half mu square. Kinetic energy final at the maximum height is equal to half mu square cos square theta. Okay, they are asking us to find the ratio. So that is kinetic energy at the point of projection and at the maximum height is equal to half mu square by half mu square cos square theta. Mu square cancel. And what's the angle of projection? Angle of projection is 30 degrees. 1 by cos of 30. Cos 30 is equal to root 3 by 2 whole square. That will be equal to 4 by 3. So that is option 4. Option 4 is the correct answer. 4 by 3. Okay. Right. Next. Here we have another question. The range of projectile projected at an angle of 50 degrees with a horizontal is 50 meters. This one at an angle of 15 degree, horizontal range is 50. Let me take it is R1. Let me take it is R1. R1 is equal to 50. Next, it is theta 1. It is theta 1. And if the projectile is projected with the same velocity, angle of 45 degrees, theta 2 is 45 with horizontal, then its range will be R2. So you have to understand one thing here. Theta 1 is equal to 15 degree, theta 2 is equal to 45. Does these two are complementary angles or not? First we have to verify. Okay, because projection velocity is the same. R1 and R2 will be same for complementary angles, but we need to verify whether the angles are complementary or not. Now here theta 1 is equal to 15 degree, theta 2 is equal to 45 degree. These two are not complementary because theta 2 is not equal to 90 minus theta 1. So we cannot say these are complementary angles. So usual formula we have to use. Usual formula R2 is equal to, R2 by R1, I'll take ratio u square sin square 2 theta 2. Sin 2 theta 2 only. You take ratio R2 is equal to sin 2 theta 2 by sin 2 theta 1, u square will be cancelled out. This is equal to sin of angle is 45 degrees, 2 into 45 degree by sin of 2 into 15 degree. This is equal to sin 90 equal to 1, and here it is sin 30 is equal to 1 by 2, 1 by 1 by 2, which is equal to 2 by 1, right? R2 by R1 equal to 2 by 1. This R2 is equal to 2R1, nothing but 100 meters. So that is 100 meters. Here it is, first option is correct, 100 meters. Okay, right. Next, we have another question. Look at this. Two projectiles are projected 30 degree and 60 degrees with a horizontal with the same speed. The ratio of the maximum height attained by the two projectiles respectively is. So ratio of the maximum height attained by two projectiles. One thing you need to understand, 30 and 60. 30 and 60 are complementary angles, right? 30 and 60 are complementary angles. And here h1 by h2 is equal to, they are asking h1 by h2. h1 by h2, u square will be cancelled out. Sine square of theta by sine square of 90 minus theta becomes cos theta. This is equal to tan squared theta, you can write, which is equal to tan of 30 degree whole square. Tan 30 is equal to 1 by root 3 whole square, it becomes 1 by 3. So 1 by 3, option 4 is the correct one, right? Okay, tan 30 is the 1 by root 3, 1 by root 3 whole square, which is equal to 1/3. Clear? So these are some questions on projectile, that too oblique projectile. Okay, right.